Okay, let's learn how to draw a cyclohexane ring. I'm going to try to draw this as a chair. And that's our chair. And that's a reasonably okay chair. A lot of people, when they draw chairs, they make them super flat. And this is bad. So no super flat chairs. And then you don't want super steep chairs. So we don't want to get a bunch of vertical lines going on here. So that's also a no. Your chair needs to have some tilt, but not too much tilt. That would be that. Okay, so let me draw over here. Why do we call this a chair? Well, because you can kind of imagine your molecule sort of leaning back and kicking like this, a little smile, because it's in a chair. Okay, perfect. So that's why we call it a chair, because it looks like a recliner chair. Now let's redraw this structure down here. There's our cyclohexane. This is great, except for we haven't shown any of our hydrogens. So we need to fill in our hydrogens. I'm going to first fill in the axial hydrogens because I think they're the easiest ones to see. The axial hydrogens will be vertical, up or down, based on the orientation of the carbon. So you see how this carbon has two bonds, and the two bonds to this carbon kind of collectively point down? That means a hydrogen on that carbon is going to be straight down. And this is the axial hydrogen on this particular carbon. Now, notice these two bonds kind of point down to this carbon. Therefore, that hydrogen is straight down. Same is true for this one, so that hydrogen is straight down. 3 of our hydrogens will be axial down. 3 of our hydrogens will be axial up. And they're on the other 3 carbons that we haven't highlighted. So there's an axial up, there's an axial up, and there's an axial up. Fantastic. So let's fill in the equatorials now. The equatorials kind of will all radiate out from the central point of the molecule. And they'll radiate out in the opposite direction of the axial. So you see this axial is an axial down. The equatorial will be just gently slanted up. So every carbon will have a hydrogen. One is going to be up, one's going to be down. In this case, the axial is down and the equatorial is up. So if this hydrogen is already axial up, then the equatorial must be down, but it's going to be gently down. This one, there's already an axial up, so equatorial down, axial down, equatorial up, and again, the hydrogens will always go away from the center dot. And then this carbon right here has an axial down, equatorial gently up. Here's an axial up, equatorial gently down. Whew, okay, that's a lot of work. Now, here's the bad news with chairs. Molecules have 2 chair conformations, and they can undergo a flip. So there's another conformation that we can draw here, and it is going to be the flip version of this chair, which means this carbon is kind of pointed down. It's now going to be pointed up. That's actually a better chair there. Okay, so here's carbon 1. It's on the left. This is carbon 1. It's on the left. 2, 3, 2, 3. 4 is on the end. I'm not going to bother drawing 5, but there's 5 and 6 over here. And we got a 5 and 6 on this ring as well. Now, this is where it gets interesting. When we flip this chair, this hydrogen, this starred hydrogen, it was equatorial up. It's still going to be up, but now on this carbon, the hydrogen that's pointing up is now axial because both these bonds to this hydrogen point up. That starred hydrogen went from being equatorial up to axial up. That means this particular hydrogen is going to go from being axial pointing down. It's still going to be down, but it's going to be equatorial down. Let's throw in our center point. It's going to point kind of away from that. So we have one hydrogen up and one hydrogen down. And that's true for all the hydrogens on this ring. This hydrogen was axial up. It's now going to be equatorial up. And this hydrogen was equatorial down. Now is going to be axial down. So we can go around the ring, filling in our hydrogens. And I'm going quickly here because the video is long, or getting long, but this will take some practice. But every carbon has two groups on it. One is axial, and that group can either be axial up or equatorial down, or in the other chair, it's equatorial up, axial down. Take some practice, but we'll get a feel for this. And we'll see more examples as we work through more of this little unit.